Welcome back to the hyperbolic coding chamber. Sad days today, but we must venture forward and go forth. That being the case, the grind has been going well. I've been dabbling in some other side pursuits, which have also been pretty dope. But even better than all of these things combined, we have a comment that I kind of peeped at, and it might be the best comment ever seen on camera. So we have a comment from Thomas Wong, legendary GOAT, visionary thinker, entrepreneur, part-time gardener, professional computer toucher, foremost algorist, as well as trusted friend, colleague, and lifesaver. We have Thomas Wong here saying, "Brother, I did count days together, LC2409, which is count days spent together. This problem, low-key, kind of beastly, but we were still able to dunk on it somehow. Took me 47 minutes and I nearly choked it during the contest. I would say it's definitely not towards the easier side of the easy. I agree. Date problems are slept on just because there's so much little points to handle correctly that it can be a little frustrating." Then he says, "I would say it's similar to one of the LC medium interval problems." True. Very true. Very, very true. What I did during the contest was to translate the date, e.g. Alice arrived on the first day of Feb into 32 out of 365. Working with numbers is much easier than working with dates, IMO. I agree. I did the same thing. And I think that was the easiest way to do it. Yeah, I think that's what we did. But I also think we did a simulation-based version, actually, which is what we did here, because we got a little caught in the sauce. But we tried that earlier, and I think we could have gotten there. But in the end, we were bested. We figured it out, but it wasn't the ideal solution. Even better, though, Thomas says, "I guess I kind of stopped LeetCode since I got a new job. Let's go! Let's go!" At one of Australia's largest telco as a software engineer. Feels strong, man. Have lots to learn at new job. Heaps of DevOps knowledge. If you know, the heap is the hardest data structure. CI/CD, Kubernetes, Ansible. These words are crazy. No, we do not know what they mean. JK, something to do with DevOps for certain. I've never touched Kubernetes or Ansible, but those are the marks of the beast. And then front end and back end, so I guess I won't be grinding LeetCode as much as I used to, but I will never forget the days I did LeetCode for hours and waking up every day seeing a LeetCode video and commenting on it. Feels strong! Watching your video every day gave me a lot of motivation moving forward. That was during my darkest times. Thank you, Manny. Never give up. Thank you, brother. Thank you. We cannot stop. If you're doing LeetCode right now, you cannot stop. The end is coming. Your future self will save you. Even if you don't get the ideal job, even if you don't get the ideal position, your future self will thank you, because the path of forging discipline is a long and arduous one. But they say, fruitful is the man who plants seeds for the fruits he may never harvest. But fortunately, the seeds of discipline always pay us back. So this is incredible, man. I'm just trying to get TBH. I'm just trying to get like Thomas, and it doesn't get any better than this. So this is just a feel strong, man. Feels strong. Happy to have known you, brother. Please hire me when you make it to the top. I am a broke boy. Feels strong, man. HCC respect. HCC mourns our loss of you, and we look forward to your successes, brother. It doesn't get any better than this, man. This is crazy. This is just crazy, man. It doesn't get any better than that. Yeah, now I'm imagining the day we finish that last LeetCode problem, and then the LeetCode CEO is going to show up and say, "The company's yours." And then we'll be done. And then we'll basically be done. And that day, it's about 400 days out from now, but just reading Thomas's message, I feel like I'm basically living for this right now. So just a little bit of taste of Thomas's success, man. it's making me my mouth water for our own. So that is incredible, man. And yeah, it doesn't get any better than that. That's just crazy. Also, check out Thomas's channel, legendary videos as well. Also documenting the LC journey, but also just the journey through life. So that's pretty cool. And we have Ishan Jagani. Which application are you using for getting that problems? This is one of the earlier days. Day 3, it never ends. It was a struggle of time at the time, actually. But at the time, I was using an application I created to basically, it's basically space repetition for LeetCode. And a lot of people don't recommend not memorizing problems. It's kind of about memorizing problems, but not really at the same time, because memory does increase performance. And we do know that memory is one of the greatest predictors of chess grandmasters. So, not to say that chess is LeetCode, but LeetCode is probably chess. And yeah, that's why we were doing it. Not trying to say we were trying to memorize all the problems, just the fundamental problems. And yeah, doing this in the beginning really helped a lot. But we still have a long way to go. And yeah, the problem it was an application I made for space repetition of practice. Yeah, so the general idea is we would do a problem, right, that we could solve, and then we would, see it 3 days from now, and I would try to solve the same problem but using a different method, or I would try to solve the same problem, try and get a better time complexity, and so on and so forth. And the idea that each time we do the problem, a little bit more would fall in, which was our experience, which was pretty awesome. And that was pretty much the goal with that. And it was incredible. Unfortunately, the time it took to review problems eventually grew, which is always the tough problem with space repetition. I know there are some better algorithms now, like in SuperMemo, pretty much has the best space repetition algorithm invented by man. But also, the person who made SuperMemo kind of invented space repetition. So, yeah, there was no way I was going to implement a version of the spacing algorithm that was better than, I think they have like V1, which is open source, and like V17, which is what's in the newest SuperMemo, I think. But our version is not even V1, which is the ghetto version we put together. I tried to cobble up one that made sense, but in retrospect, it didn't make a ton of sense. So it helped a lot. I would recommend trying to do something similar if you're having a cold start problem. But yeah, that's where it's from. But yeah, that was incredible. I think Thomas's comment will sustain us for the next 200 days, and hopefully we can taste our own success in the meantime. That being the case, some of you may remember a series of videos about LeetCode on the channel called Far From Home. That is going to have another sequel, possibly next week, but we shall see. And I'm thinking for this week and next week, just because we might be somewhere different and general life things, I think for this week and until next week, we might go down to 30 minutes, and then after that, we'll resume back at an hour. And we might sprinkle in a couple hour sessions, but I think just with time constraints, it might not work super well. So we shall see. We'll have more information, but yeah. So that's kind of where we're at. And yeah, we have more LeetCode to do. And super shout out to Thomas, super shout out to Ishan Jagani, as well as everyone else who's been showing up. If you're interested in something like this, or you want to get into LeetCode, we have legendary LeetCoders in the Discord who are practicing and battling elements every single day. I think we have people from Meta. We have people from Meta. I think someone said they are from 2 Sigma, and then I'm relatively certain we have someone. For some reason, I'm getting a vibe that someone's from Twitter. So, yeah, that's going to be the wave. Hopefully, we can get on their level. But, yeah. So, that's kind of where we're at. And we're going to do some more LeetCode. And I think today we're going to do a standard 30-minute sesh. If we're feeling strong, we might go further. But I'm going to be honest, today has been a little draining. So, we might not do a ton here, but we're definitely gonna do 30 minutes. I promised 30 minutes yesterday, and we did more than that. So that's where we're at. So we did count days spent together. And then we have check if all A's appears before all B's. So given a string S consisting of only the characters A and B, return true if every A appears before every B in the string.
Electric vehicle, an EV that produces zero tailpipe emissions that contribute to climate change.
Electric vehicles are worth watching, and there's an EV that's right for just about every lifestyle. Head to SeenOnEV.com to learn more.
I think we could do this in linear time. If we get the index of the last A and the first B, we can simply check that the first B is greater than the last A. And this should be true, because if we had an A passed here, right, then the last A would actually be at the end, right, and the first B would actually be here, which would be incorrect. So I think if we get the first A and the last B, so let first A index equals -1, right, and we're going to have last B index equal to, actually we're going to have first A index, we're going to want the small, no, we want, I forgot what I meant, we want the last A index, right, and the first B index. If we want the last A index, it means the index that we're going to have for A is going to be the largest index. If that's the case, it's okay for us to start at -1, but if we want the first B index, the value we want is actually going to be the smallest value. So we probably want to set it equal to infinity, or we can set it equal to s dot length, right? And so to calculate this, we're basically just going to say for let I is equal to 0, I is less than s dot length, right? We're going to say if s sub I equals A, right? It means we have an A index, right? We're going to want to set last A index equal to the math dot max of last A index, right, and index of I. We can duplicate this, right, and we're going to do this for first B index. The first index is going to be the smallest value, and then we're going to make sure that S of I is equal to B. Fortunately, we can actually start this at, actually we'll just start it at 0 to make the algorithm simpler, and I think we should just be able to return that last A index is less than first B index. And just before we run it will make sense, we should get 0, 1, 2, and 3. Is 2 less than 3? It is. And I'm pretty sure we can also do it in one pass if we keep a couple variables in hand. In this case, A index is going to be -1, and the first B index is going to be 0. In this case, -1 is still less than 0. Now let's just say it's all A's, right? Last A index is going to be 3, and 3 will still be less than the length of the string, which will be actually the last index will be index 2, which will still be last A index will be 2, which will still be less than 3. So this should work, but we'll see right now. So that's pretty cool. There's got to be a way to do it in one pass. What we basically need to make sure is that there's a long running sequence of A's, right? So we can have like some kind of simulation thing, and we'll say let crossed boundary equal false, and crossed boundary will represent whether or not we've crossed the boundary into all B's. So we'll say if S sub I equals B, right, then we'll say crossed boundary equals true. But only if we haven't crossed the boundary yet. Right, if S sub I equals B, right, and we haven't crossed the boundary yet, we'll set it equal to true. Right, now we can check again. If S sub I ever equals A and we've crossed the boundary, we can return false. So in this case, right, as soon as we reach B, we'll say we crossed the boundary. If we cross the boundary and S sub I ever equals A, will return false. That is not happening there, so we're okay. Now we have A, right? We get B, we cross the boundary into B, right? But then we find A, so we'd return false. And I think this should, if we have all A's, right, we'll never cross the boundary, so we'll return true. If we have all B's, we'll cross the boundary on the first one and never run into an A. So that works too. So that's pretty cool. And then we'll have second largest digit in a string.
Hey YouTube music listeners. With an Omen gaming PC, you can do it all. You can be the always streaming, content creating, quick thinking, endlessly dreaming version of you. Powered by 12th gen Intel Core i7 processor. Learn more. Visit omen.com/omen16.
I think you can do this in 2 passes. So we'll say largest digit, right, is going to be equal to -1. Right, and we'll do it in 2 passes. So we'll go through and we'll say for let I is equal to 0, I is less than s dot length I plus plus, right? If s, so we're going to pass this into parse int. I don't remember the ASCII value of 0 through 1, so we use a kind of a weird version, but we'll just say something like we'll just say digit set, right, which would be a new set that we'll create from an array, and we'll just load it with all the digits, and then we'll say this is going to be pretty much all strings. right? We're gonna say if digit set dot has s sub I, it means it's a digit. If it is a digit, right, then we're gonna say largest digit is going to be equal to the math dot max of largest digit, or parse int of s sub I. Then we can run this again. Right, if there's no digits, we'll return -1. There's no largest digit, right? There's no second largest digit. And then we'll do here, we'll say second largest digit is equal to -1. Right, we're gonna go through all of it again. If it's a digit, right? And if parse int of s sub I, right? Parse int of s sub I, then we're gonna say, I forgot what I was gonna say. Oh, right, num has to be less than largest digit, and if it is, right, then we want to take the max of those options. So second largest digit to math.max of second largest digit and num, right? And then we'll do the same thing, right? We'll return if second largest digit equals -1, we'll return -1, otherwise return second largest digit. I feel like this should work, but we'll see. So somehow this seems to work. This should be 2 pass. I'm not really certain how you would do this in 1 pass. Probably faster if we do the ASCII values, but we'll take it. We have X of a I hate card problems. You are given an integer array dec, where dec sub I represents the number written on the ith card. Integer array dec, where dec sub I represents the number written on the ith card. Partition the cards into one or more groups such that each group has exactly x cards where x is greater than 1. And all the cards in one group have the same integer written on them. So break the cards into groups that have the same numbers. Well, okay, so we could load all of these into a map, and then we'll just dole out the map. The map will be a number to an array of numbers of that same number, and then since we're returning a Boolean, we'll iterate through the map and we'll check if any map has a length of an array of 1, then we can return false. In fact, we could probably just make it a map of number to number. So we'll say const map is equal to new map of number to number. We'll say for const num of dec map dot add num, right, to if map already has a value for num, get that value for num, otherwise set it to 1. And I think it's actually set. Then we can iterate for, we don't really care about the key, but for the occurrence of the map, if awk equals 1, we'll return false, otherwise we'll return true. Oh, I was really confident in that one. Oh. Wait, no. Oh, we need to do map.getNum plus 1. So I'm not understanding why this is false. Do they all have to have the same? Oh, each group has the same number of cards. So they should all have 3 cards. So we'll just pick a random occurrence for a random number in the array, and they should all match this number. And if they don't equal that expected occurrence, so maybe it's a mixture of both of these. If occurrence doesn't, they all have to match. Or if awk equals 1. This problem may not be that simple. Awk does not equal expected awk, or awk equals 1. I don't think I understood the problem thoroughly. I should have read through the whole thing. At most, the best we can do is choose the largest value for the partition groups of the smallest value of the occurrences. In this case, that's a size of 2. If something doesn't equal this size, we can actually go through again, and if it's odd, to simplify it, we can mod all the occurrences by 2. If everything equals 0, then we're good, and we'd basically have 2 different styles. Actually, even if it's odd, it would be the same thing. If the value is 17 and the smallest value we have is 3, we would try and blend all the part groups together such that it would be equal to 0. If there's a partition that exists, it's either odd or all even. So if we pick the smallest amount if the smallest group equals 1, we have to return false, because we need at least 2 to make a group. Additionally, we can go through the map, right, and we can ask the question, right, if awk mod smallest group does not equal 0, we can return false. And if it does equal 0, it means there's some way we can split it up such that it equals a group. For example, if there's 9 sevens and the smallest group we can make is 3, then if we do 9 mod 7, we should get 0, which means there's some version that we can break up groups into such that we get those values. One, 1, 2, 2, 3, 3, 4, 4. So I'm actually not following here. The smallest group here is 2. If we do awk mod 2, we get 0. Let me just print the smallest group. Something seems off. Oh, if we're doing map.min, we can't do that. Map.getNum is greater than 1. Otherwise, it gets set to smallest group. Still 3. Wait, so this one should actually be true. Why is our smallest group 2? Our smallest group here is actually our smallest group is small for some reason. If the map has the number, right, then we get the number it has plus 1. Otherwise, we set it to 1 because it's its first occurrence. Then if map.getNum is greater than 1, then we'll set it equal to the math.min of smallest group and map.getNum, which would be 2 when we do get 3. Right. I think this whole thing would be simpler if we just did it here. After we've calculated everything. So we have 3 ones and a bunch of 2s. They expected true, we return false. Smallest number of ones. Oh. Right. It's not that the smallest it's not that the smallest group is equal to that value, but that if it's even or odd. Right. So we have smallest group. We take smallest group, right? We'll say if smallest group mod 2 equals 0, then the smallest group they can have is 2. Otherwise, the smallest group they can have is 3. Doesn't make any sense to me. What group can you split up? You can't split up 2 groups that have odd and even amounts into such, some amount of groups. Smallest group. There's no even number that goes into 423. Now I'm starting to think if all the numbers are odd, there is some way we can split this up. Maybe. We have 3 and 7. Right. Both are odd. There's no way to split those up. I think there's one more thing we could try. We can say all even, which is equal to true, right? And all odd, which is also equal to true. As we're going through, we'll say if awk mod 2 equals 0, right? Then all odd gets the value of false. Else, right? If awk mod 3 or awk mod 2 does not equal 0, right? All even equals false. If they're all even, we can return true. If they're all even, there's some way you can split this up, smallest being 2, such that they all have the same number of groups. Otherwise, if they're all odd, we have to do another loop over where we check whether or not awk mod 2 does not equal awk mod smallest group does not equal 0. No, if awk mod, if awk dot smallest group is not equal 0, we'll return false. And then at the end we can return true. And I feel like this should work. All odd has even equal to true has odd will be equal to true. Now if has even and has odd, we want to return false. There's no way to split this up.
The YouTube Music app has mixes made to fit every mood. Seriously, every single one. Get YouTube Music Premium.
Never mind. You can have all even and odds. What am I saying? We need to take a look at this tomorrow. We're not thinking, we're just trying a bunch of nonsense. So I think we'll come back to this one tomorrow.